This video is going to cover Chapter 7, Section 8, which is Applications of Matrices and Determinants. So really, we're going to be doing the determinants a bunch in this section, just learning how to use them for different reasons. And here's the first. The area of a triangle can be found if you have the coordinates of all three vertices. So if I have a triangle and I know the three vertices, for example, if this was like 1, 4, negative 2, 7, I don't know, negative 3, 4, something like that. If I wanted to find the area of this, then I am going to take my x and y values and put them in the first two columns of a matrix. So I would do, in this case, and it doesn't matter what order I do, if I do this one first, so it'd be 1, 4, then negative 2, 7, then negative 3, 4, and then I fill the third column with ones. And then I'm going to find the determinant of this area. I'm going to multiply it by a half, and I'm going to make sure it's positive. So where the plus or minus is, if it's negative, I'm turning it to positive. If it's positive, I'm going to keep it positive. So again, putting coordinates in the first two columns, putting ones in the last one, and then finding the determinant of the 3 by 3. Okay, so example 1, find the area of the figure with the given vertices. We're going to rewrite these in the first two columns. Negative 2, 4, 2, 3, negative 1, 5. And then we're going to fill the third column with ones. We want to find the determinant of this, so we're going to repeat the first two columns. Negative 2, 2, negative 1, 4, 3, 5. We're going to multiply down these diagonals first. So negative 2 times 3 times 1, negative 6 times 1, which is negative 6, 4 times 1 times negative 1, negative 4, 1 times 2 times 5, 10. And then we add these together. Negative 6 minus 4 is negative 10, plus 10 is actually 0. Then we go back the other way. Negative 1 times 3 times 1, negative 3, 5, 1, negative 2, negative 10, 1, 2, 4, positive 8. Add these together, negative 13 plus 8, negative 5. And then we do the first sum, 0, minus the second sum, negative 5. That becomes plus, and I get 5. And then that is the determinant part, but then we do 1/2 of that. 1/2 of 5 could be 5 over 2. It could be 2.5. It could be 2.5, anything like that. And again, if it was negative, we'd make it positive, and this is area, so it would be units squared. This example says, find the area of the shape that's given. And this is actually a parallelogram. Opposite sides are parallel, opposite sides are congruent. So while a parallelogram is a quadrilateral, it is also two triangles put together and two congruent triangles put together. So I can pick any points, this one, I could pick those 3 points, or I could have gone the other way and picked these 3 points. It doesn't matter. If I would probably choose to go with the positives first, but really it doesn't matter. And then I'm going to find the area of that triangle by doing what we just did, and then I'm going to double it. So negative 3, 2, 1, 2, negative 1, negative 4. Fill the last column with ones. Duplicate the first two columns. Multiply down these diagonals first. Negative 3 times 2 is negative 6 times 1, negative 6, plus 2 times 1 times negative 1, negative 2, plus 1 times 1 times negative 4, negative 4. Negative 6 minus 2 is negative 8, minus 4 is negative 12. Then I want to go back the other direction. Negative 1 times 2 times 1, negative 2. Negative 4 times 1 times negative 3, positive 12. 1 times 1 times 2, positive 2. Negative 2 and positive 2 cancel, and I just get 12. And then I would do negative 12 minus 12, and I get negative 24. I make it positive always because area is positive. And normally I would cut it in half to get just that one triangle, which would end up being half of 24, which is 12. But I'm going to double it to get the whole parallelogram, so I can just leave the 24, again, units squared. All right, next up is the test for collinear points. So you can also use the determinant to determine if 3 points are collinear or lie on the same line. So we'll take those 3 points, we'll fill the same columns and fill the last column with ones like we just did. And if this determinant equals 0, then it means it would have 0 area, which means that it would be collinear. So if what we just got from the last one is 0, then our points are collinear. Example 2, determine whether the points negative 2, 2, 7, 5, and 1, 1 are collinear. So negative 2, 7, 5, 1, 1. We're going to fill the last column with the ones. We're going to duplicate column 1 and column 2. We're going to multiply down these first. Negative 2 times 5 times 1 is negative 10. Negative 2 times 1 times 1 is negative 2. 1 times 7 times 1 is 7. Negative 12 plus 7 is negative 5. Go back the other direction. One times 5 times 1, 5. 1 times 1 times negative 2, negative 2. 1 times 7 times negative 2, negative 14. So I get 3 minus 14, which is negative 11. Negative 5 minus a negative 11 gives me positive 6. If that number's 0, they are collinear. Because it is not, these are not collinear. Okay, last up is Cramer's rule. We're going to use Cramer's rule to solve a systems of equation. And we're going to do 2 variable and we're going to do 3 variable. So this is a tedious process, but if you can do the determinant, you can do this. To find the solution to a systems of equation with 2 variables, you're going to find 3 determinants. You're going to find first the determinant that we will call just D. And to do that, we'll take the x values and the y values. So x1, y1, and x2, y2. So we take both the coefficients from the x's and the y's, and then we'll do the Jesus fish and we'll find this value. Then we're going to repeat it to find what we'll call d of x. But with d of x, we take out the x's and we put in the constants. So for this one, we put the constants and in that column. So the constants go in the first column. Then we put the y's in the second column. Again, we'll do the determinant to find d of x. Then we find d of y. And this time, we go back to the initial and we take out the y's and put in the constants. So the x's stay, and then the constants go where the y's are. And then you'll use the determinant and you'll get d of y. And then to find your x, you're going to do, which I think is a little bit confusing, what's written here. To do your x, you're going to put d of x over d. And to get your y, you're going to put d of y over d. So you're going to do the determinant 3 times and then set up the ratios. All right, so it says use Cramer's rule to solve the system. First thing we're going to do is take our system and rewrite it in matrix form. 2, negative 3, negative 11, 1, 2, 12. Now the first column are our x's, the second column are our y's, the last column are your constants. So to find d, we do the x's and the y's. 2, negative 3, 1, 2. We're going to come back and find that determinant in a minute. To do d of x, we remove the x's from that first one, and we put in the constants. So negative 11, 12, the y's stay the same. To find d of y, we're going to keep the x's, but replace the y's with the constants. And now we're going to find the determinant 3 times. So 2 times 2 minus 1 times negative 3. 4 minus a negative 3, which becomes 7. D of x. 2 times negative 11 minus 12 times negative 3, negative 22 minus a negative 36. That becomes plus, and this is 14. And then the y, d of y, 2 times 12 minus 1 times negative 11. 24 minus a negative 11. That becomes plus, and this is 35. And then to find x, so this is d of x, and this is d of y. To find x, we put d of x over d, 14 over 7, which is 2. And to find y, we put d of y over d, 35 over 7, which is 5. And then the solution to the system is 2, 5. If you want to pause the video so you can practice this one, you can. And then when you're ready, unpause it and we'll go over the solution. Okay, so d, we left the x's and the y's and got that d would be negative 16. D of x, we took out the x's and replaced them with the constants and got d of x would also be negative 16. And d of y, left the x's, replaced the y's with the constants and got d of y is 32. Negative 16 over 16 is 1. 32 over negative 16 is negative 2. So our solution is 1, negative 2. Now, just when you thought it couldn't get any more fun, we're going to do Kramer's rule to solve systems with 3 variables. So this time, much like the last time, we're going to find determinants, but this time we're finding 4. The first one we find is all the x's, all the y's, and all the z's. D of x, we take out the x's and replaced it with the constants. You leave the y's, you leave the z's. D of y, you leave the x, you replace the y's with the constants, you leave the z's. And D of z, you leave the x, you leave the y, and you replace the z with the constant. Then you're going to find 4 3x3 determinants. And then x is d of x over d, y is d of y over d, and z is d of z over d. So a lot of work, but less than Gosh Jordan. All right, example 5. First thing we're going to do is set up our matrix. So negative 2, 1, there's no z this time, so 0. Make sure you put that in there to hold a place. 1. 1, negative 1, negative 2, 2. 3, 1, no z again, so 0, 6. Now to find d, we do the x's, the y's, and the z's. Negative 2, 1, 0. 1, negative 1, negative 2, 3, 1, 0. I'm going to leave off that second bar because I'm going to come back and fill that in doing the determinant. Now d of x. D of x, we take out the x's and put in the constants. 1, 2, 6. Do all the y's. 1, negative 1, 1. Do all the z's. 0, negative 2, 0. D of y, we leave the x's. Negative 2, 1, 3. Replace the y's with the constant. 1, 2, 6. Keep the z's. 0, negative 2, 0. And last up, d of z. We keep the x's. We keep the y's. We replace the z's with the constants. Now I'm going to go back and do the determinants. So repeat the first and second column. Multiply down the diagonals. This would be 0 minus 6 plus 0, so negative 6. Come back the other way. 0 plus 4 plus 0, 4. Negative 6 minus 4, and d is negative 10. Go to the next one. Duplicate the first 2 columns. Multiplying down the diagonals first this way, 0 minus 12 plus 0. And come back the other way, 0 minus 2 plus 0. and I get negative 12 minus a negative 2. That becomes plus, and I get negative 10. Now, if your answers are all supposed to be whole numbers already, you can check to make sure d of x over d would give you a whole number. Now go to d of y. Negative 2, 1, 3, 1, 2, 6. Again, multiply down the diagonals this way. 0 minus 6 plus 0, negative 6. Multiply down the diagonals this way. 0 plus 24 plus 0. Negative 6 minus 24, negative 30. And the last one, negative 2, 1, 3, 1, negative 1, 1. Multiply down the diagonals this way. Positive 12 plus 6 plus 1, 19. Come back the other way. Negative 3 minus 4 plus 6, negative 1. 19 minus a negative 1 is 20. And then we put d of x over d of y for x. So negative 10, d of x over d over 10, which is 1. For y, d of y, negative 30 over d, negative 10, that's 3. And for z, d of z over d, negative 2. And my solution is 1, 3, negative 2. All right, that's it for the video for today. Use the remaining, submit these notes. And then use the remaining time to start the 7.8 homework. Have a great weekend, guys. I'll see you Monday.